Buon pomeriggio, bentrovati o ben ritrovati per chi c'è già stato ad EIMA Digital Terra, EIMA International 2024. Ultimo giorno di conferenze, di appuntamenti legati al mondo dell'agricoltura digitale. Oggi andiamo a parlare di droni, e di diverse applicazioni dei droni, diciamo in agricoltura, ma in realtà forse è un po' restrittivo. Parliamo anche di monitoraggio, per esempio, del bestiame. Per diversi sono i casi d'uso che sono stati analizzati all'interno del progetto, ma ce ne racconteranno meglio coloro che del progetto si occupano. Io cedo subito la parola a Giacomo Carli, Senior Lecturer dalla Open University United Kingdom. Giacomo, io ti prego di prendere il microfono, lascio a te il palco e io mi rendo disponibile a fare la valletta per le domande finali.
Buon pomeriggio a tutti. Giusto un controllo. Is there anyone who wants the presentation in English? Just two people? What? 3, 4? I would say I do my presentation. I start in English, then we do a part in Italian, and then back to English.
Is everybody okay with English as well? Okay, so let's do it in English.
A little bit of exercise for the Italians here, like me. Forgive my English is not perfect. So welcome to the presentation of ICAERUS. ICAERUS is a project founded by the European Union, and the agenda of today is to be introduced to the project, see the 5 use cases, and be introduced also to the course that is free and developed for everyone. See an example of a project that we founded in our project, because we offer funding to several stakeholders, including companies, to develop technologies. And then we will see again a little bit more of the use cases and the next steps of the project. So we mix technologies and business, basically. ICAERUS is a project that started in 2022 and is funded by the European Union with the taxes of all of us, including the people in the UK. And it has an endowment of around 6 million, so there are very strong expectations by the Commission regarding the technologies that we develop here. These are the partners. There are 3 universities: Agricultural University of Athens, the Open University, and Wageningen in the Netherlands. Plus, there are 5 companies, Numena in Spain, IDEL, which is not really a company but an institute in France, 2 companies in Greece, and AgriFood Lithuania, and no, I said all of them, I think. Yes, 5. And 1 in North Macedonia. Sorry, AG Futura is in North Macedonia. It's very important to distinguish the 2 countries. Vision of the project is to explore the opportunities of drones in several applications, not just agriculture, as it was said at the very beginning here. Am I going too fast with my speech? Do you follow me? Is that all right? Okay, good. Aim of ICAERUS is to showcase and support the development of applications, so to transform the technology into business, using different approaches, from training for people in the technologies, showcases with demonstrations, also inviting farmers to develop their abilities in using drones, and offering them the example of projects like Agrobit. So it has a component of research involving several actors and developing these 5 new technologies, and studying also the benefits of the adoption and how to make drones more enjoyable to adopt as technologies by different kind of stakeholders. Second, develop and demonstrate this technology, so to transform the idea into something applicable. Educate and train, which is the part that I lead, which is basically developing the business knowledge of people who are mainly technicians, and they want to develop a company to offer their services because perhaps they like drones and they pilot drones, but they have no idea on how to develop a company, and especially start a company and getting the funding that each European country is offering. So how to become able to grasp those opportunities. And finally scale up our European system that is a little bit behind in comparison to the US and to China. So this is more or less what we are developing. I will not cover all of this, but we have developed a series of different results. One is interesting one is the study of the market landscape. So one of the deliverables will be an analysis of the industry, which leads to the data analytics library. All the software used for the 5 use cases is available to download and implement if you want to try it on your drones. So all the libraries will be made available on the ICAERUS platform. Socioeconomic impact and business models that can be replicated in different contexts. And finally, the ICAERUS Academy that contains the course that I'm developing. The 5 use cases. So number 1, crop monitoring. It is developed in Spain by Nomena, and it has the ability to detect diseases on leaves or canopies, mainly vineyards. And that is done automatically. And it builds up a mosaic picture that we will see later. Drone spraying is the one developed in Greece. Is a drone that is able to spray, again, vineyards, and the use case will compare it to traditional ways of treating diseases. Livestock monitoring is a totally different application. It's a drone that monitors the position of sheep or cows around where they are, and they have a collar which basically transmitted to the drone, so it's possible to find where they are using that device. This is all working. Livestock monitoring is one of the most advanced use cases, and it's already showcased as a technology in France by IDEL. Forestry biodiversity monitoring has a series of applications that goes from monitoring the health of forests, but also finding wild animals in the forest, wild pigs, bears, or even humans in the forest if they got missed. Rural logistic is a typical transport drone, but the transport drones are not that advanced. Here it's a fleet management system that delivers packages up to 30 kilos without piloting. Is automatic. So the difference is that it does the routing by itself. So it's a totally different kind of technology that combines different modules in terms of software together to manage the fleet. I hope this introductory part has raised some attention. I presented the work packages. So basically, ICAERUS is done by 7 work packages. One is the stakeholder analysis and the analysis of the industry. Number 2 is the technological part related to software, so all the software library development. Number 3 is the use cases development and the analysis of their sustainability in terms of socioeconomic sustainability and environmental sustainability of the technology. Number 4 is the one that I chair as a PI, as principal investigator, and is about basically the development of training for all the stakeholders who want to know more about drones. Number 6 is the platform, so basically a collector of all the knowledge in a way that is accessible to human beings. So perhaps not always the boring papers that I write as an academic, but something more accessible to human beings who are interested in learning something without get bored by reading a paper of 20 pages that perhaps says a couple of concepts. So something accessible to everyone. I go a little bit in detail about this. We developed a course of 24 hours in terms of time that the learner would dedicate to read it through. It's online and asynchronous, so it's basically on a website and it's for free. So everybody can look at it. It talks about drone industry, drone application, development of business models using drones. We started identifying the needs of Europeans around the drones. So we interviewed, even in Italy, I came in Bologna and I interviewed 5 people. Some of them are presenting here today their technologies here at EMA. And collecting their ideas, we developed the content of this course. We took almost 2 years. The full course will be live before Christmas. We are finalizing it. It's done of 8 weeks. Week 1, business ideas identification. Week 2 is business model types, so the 4 business model types. Frameworks for regulations around drones, because as you know, drones cannot be used everywhere, especially spraying drones are a big question mark in Italy. Only in experimental conditions they can be used. So it's a very critical application. Then number 4, and data, all the data and how to monitor and collect and elaborate the data in week number 3. Number 4, from business ideas to value propositions. Value propositions are a managerial concept. Why do we teach them? Because you need to speak the language of founders if you want to get the funding. Even in here, in this project, when we give funding in the open calls, we ask to use templates that are the ones that we teach in this course. So value proposition, and in week 5 and 6, business model canvas, which is basically the way to represent a business model. Ecosystems and networks, because no company exists in a vacuum, so there are ecosystems that are based on different kind of players that interact to deliver a service to the farmer. And finally, the ability to present. So you see that it's not only technology, it's accessible to everyone. It's accessible also to the author, because I'm not a technician by nature. I'm an engineer, but I studied design management, so I can guarantee that if you are interested in drones, this is the way to approach the field. Then the technological part is in Work Package 2 and in Work Package 3 that are delivered through the ICAERUS Academy. So all the technological innovations will be accessible there. In 24 hours, I cannot transform a person into a technician using drones. This is a typical representation of a business model canvas. I show it because basically it shows that we are using the sustainability business model canvas that has the social, eco-social cost and eco-social benefits. I go back to show the link in week 1. If you click the website, it takes you to OpenLearn. OpenLearn is one of the remaining free platforms for education in Europe. It's not American, it's owned by the Open University, my university, and the whole course is free. This is week 1, and you can see here the spraying drone in this picture. The course is given for free. So get the link from the ICAERUS website and navigate it if you like it. Thank you for counting as one of our learners. We have the KPI of reaching 3,000. Riportami sulla presentazione. All right. I'm moving quickly to the end of my part. This is how we teach, so you will find a mixture of texts and templates where we explain how to build a business model to be able to present it to stakeholders, to convince them to found your business. Then the project will evolve in the last part of it, in the last 18 months, in value-added services. So we will do consulting to several stakeholders to develop further their ideas. I was a business consultant before becoming an academic, and we will meet each of the companies that are engaged in these activities to further try to develop their services in order to increase basically the business they are doing in the different countries. And we will offer them several tools to analyze the company performance. This is connected to Work Package 3. In the 5 countries where the use cases are located, there will be on-field demonstrations. So if you like to travel, you can go to Spain, to France, to Greece, to Lithuania to see the demonstrations. There are none at the moment for this country, because this country didn't have a partner developing any technology in this project. Is something that happens usually with European project. You create a team, and if you get founded, it is like that. But if you are interested, they are also recorded online. Why do I say that? Because this is connected to the use cases and to the open calls that are linked to these use cases, because we gave funding to several companies that are connected to each of the use cases. Today you will see a case where the connection is very strong to use case number 1, which is about monitoring. Monitoring of, in use case 1, leaves and canopies. We will see in Agrobit a different kind of activity, but still linked to monitoring and decision support. So basically, you see the connection between the technology of the use cases and the open calls. In terms of dimension of the open calls, 1 million is given to several companies, 20 in total, between 50,000 euros and 60,000 in 2 types of open calls. Agrobit was in the first type, if I'm correct. Finally, the ICAERUS platform, which is the platform where you can find the link to the Open Learn course, but also all the software libraries that are used for the use cases. Of course, not everything is complete, because this is an ongoing project that ends in 2026. So in 2026 you will have the full pictures. Otherwise, the European Union will not pay us. I now move to, next steps. So what I do after finishing the Open Learn course is to work on the policy, because the Commission is very interested in our opinion, our guidance on developing policies for the use of drones, especially, you know, regulation associates them to helicopters, to airplanes, so it's very difficult to fly them, because you need to have a lot of permissions. They are trying to ask how to modify that kind of regulations and what benefits would be coming to the agricultural sector, but also other sectors. So we will inform the Commission with a report, a white paper about these benefits. And this aligns with the several aspects of the regulatory environment of the European Union. And also, I would say, of the UK, that in this case is very similar, thanks God. Next steps also for me, so the first one I said is socioeconomic and environmental analysis of each use case. And I will finish delivering with my team of 3 different academics the open online course available from this Christmas. So for Christmas, perhaps if you navigate the ICAERUS platform, you can spend up to 24 hours. At the end, you can get a digital badge, a certificate basically. Now I hand over to AgroTwin. Sorry, I said Agrobit. I'm so sorry. It's at the call.
Yes. Good morning to everybody. I'm Nicolò Bartoloni. I'm the COO of Agrobit, the name of a startup. We just gave a name to the use case for ICAERUS that is called AgroTwin. So AgroTwin is the name of the project. Agrobit is the name of the startup, sorry. Okay, so Agrobit is an Italian innovative agtech startup that develops the terrestrial imaging solution. We have 3 solutions that we call iAgro, iTractor, iDrone, for the agriculture sector to support farmers, technicians in reducing and optimizing the use of chemical inputs and water. Agrobit uses different types of cameras in combination with computer vision AI algorithms to assess crop status and relevant agronomic parameters. Our vision is to democratize access to agri-tech technologies, making precision and digital agriculture tools accessible to every farmer, to everybody. Our mission is to helping farmers and technicians achieve environmental, social, and economic resilience and sustainability goals, optimizing agronomic practices and reducing the use of chemical inputs and water, using image-based DSS, ER, and computer vision that now I am going to see. Okay, the team is, me, that I'm Niccolo Bartoloni, I'm an agronomist, and the other partners, Simone Carciotis is an aerospace engineer, and also we have another CEO of another company that you can find here in the fair, our collaborators. Our digital farming solution we call iAgro, iTractor, and iDrone. iAgro is an app for smartphone that estimates the optimal dose of agrochemical to be distributed in 3 crops. iTractor are a stereoscopic camera that are mounted on tractors to estimate grapes yield in the vineyard. We are just working on adapting these cameras to other crops. And the historical service, iDrone, drone service with multispectral thermal camera to estimate the vegetative state of crops and create digital twins. Okay. The main objective of the AgroTwin project aims to exploit 3D point cloud generated by consumer-grade RGB drones to develop a decision support system based on innovative computer vision algorithms that automatically analyze vineyard digital twin that you can see in the picture and assess for canopy biometrics and field parameters to create vigor and prescription maps for optimized variable rate pesticide treatments. The proposed DSS, will help farmers to use less inputs. We know that in a European Green Deal just stopped a little bit the aim to reducing use of pesticide by 50% by 2030. But anyway, sustainable aims are a crucial aim in the European policy about agriculture. Specific objective and scenarios, we try to make a site-specific decision-making support, resource optimization savings, improve yield and quality, historical analysis, strategy planning, to aim the sustainability targets, as I said before. Okay, the key activities and timeline about this project. We just started in November of 2023. We spent 2 months of design, making the general management of the project, state-of-the-art analysis, identification of the farm, the test winery, field test setup, and planning the drone flies. Then from January to July, we made the development of this project, and then the last 2 months for the market, contact with the stakeholder and public entities, dissemination of the results, business planning, pre-operation, market strategy definition. We have just done the demo day in Tuscany 10 days ago, with a lot of farmers, a lot of entities. The room was completely full, so we were very, very happy about it. Okay, what do we use? We use a very old DJI Phantom 3 Professional that had 8 years old, so it was very consumers. We can consider this a low cost because the value is less than 800 euros, but surely you can you can try to do this with less expensive cost drones. Then we use, why we use this? Because this kind of drone is equipped with an RGB camera that every drone has to capture high resolution images needed to generate the Vineyard 3D point clouds and orthomosaic. The acquired images are natively georeferencing thanks to the GPS integrated into the drone. This is essential for rebuild the digital twin. Then we use software algorithms. The acquired RGB images have been processing using the OpenDroneMap open source software, and the IE algorithms have been developed using Visual Studio Code open source software. And in the field, when you're just producing these maps, we use a sprayer kindly offered by the farm that we used to do this project. That was a Nobili, is a variable rate machine. And then also we made the same sampling tools. We use Syngenta water sensitivity paper, tracer, and plastic collectors. Okay, the input drone RGB images, Vineyard parameter, geographic coordinates, phenological stage, Vineyard characteristics. The output are the Vineyard 3D point clouds, the canopy biometrics, the vigor parameters in terms of leaf area index, TRV, and leaf wall area on sample vines, vigor maps, and VRT pesticide prescription maps. Okay, we use some models, algorithms that I'm not going to tell all the models, algorithms, but we use OpenDroneMap QGIS as a software and Python as a programming language. Okay, this is one of the first results. We just made the digital twin in different phenologic stage. You can see the different values of thickness, height, and volume. At the beginning in May, the volume was low, and then we started increasing during the vegetable stage. And we produced this kind of maps. This kind of maps then we gave to the farm that upload in the computer on the variable rate machine, and they use this for making treatments. Okay, the outputs, the result, we have performed several surveys with a consumer-grade drone on the test vineyard. We have successfully developed algorithms capable of automatically processing 3-point clouds of vineyards and accurately evaluated biometrics, biophysical parameters of vines. We created the digital twins. We created application maps. As the results, we have achieved a significant reduction, 35% on average, with a peak of 41 in the use of pesticide and more efficient use of water. It's very important. Improvement of the yield and quality of the grapes. There were not any difference between the test and the vineyard that we use for the project, but we made historical analysis and strategic planning. Thanks to the maps generated by the algorithms, it was possible to generate historical data useful for identifying field trends and for better planning long-term management strategy. I can add that with these kind of historical maps, we can, for example, tell more about the final products. For example, the wine. We can say we have some maps that tell us what it happens in 2024 vintage, for example. We can see, we can show. So it's very important. The impact, socioeconomic, we increase farming productivity and profitability. We make cost saving and market penetration. using these kind of tools like a drone, we can create new skill. We can create job for the new technician that wants to use this kind of tools. Okay, reducing the use of pesticide, we lead the farm to the sustainable growth. About environmental, we optimize the pesticide water usage. We made the preservation of biodiversity. We improved soil health, air, and aquifers. Also, we have a lower carbon footprint because we made less treatments. We use less fuel, less of agrochemicals, so we have a lower carbon footprint. It's replicable, so everyone can use a drone with an RGB sensor. Okay, it's better to use only one kind of drone or camera during the experimental. You can't change because every drone, every camera have special parameters. And the project aims to create a DSS with TRL7, so that at the end of the project, a complete processing pipeline will be available. This pipeline will take into input the aerial RGB images, the field parameter, the sample vantage, Gen SS position. Okay, this project concerns farmers, agricultural technicians, agricultural research and scientists, academic research institutions, university, industrial stakeholder. The project scales efficiently by using cost-effective consumer-grade drones with the RGB cameras, making precision agriculture accessible to smaller farmers with limited budgets, so every farmer can use it. By leveraging open source photogrammetry software, it avoids with high cost associated with professional tools, providing a flexible, scalable solution. Conclusion. Okay, with this project, we stress the algorithm performance. We stress the VRT efficiency. The VRT resulting in significant water savings showed potential for more targeted application based on plant parameters. Coverage and deposit, both VRT and fixed rate treatments showed over application with respect to the optimal coverage, but the VRT treatments allow the reduction of water and pesticide user. Environmental, social, economic benefits. Okay, the next step is further redefining the phytosanitary model to better assess the doses, avoiding over-application, because over-application is a real problem in all the farms. Extend research to other tree crop types to evaluate the versatility of algorithms, and test other drones. Thank you so much. Sorry for my not so good English. Bye.
Yeah, before the question, we have the last part of the presentation, which introduces the 5 use cases more in details. I'm not a technician, I'm not an expert in the development of the specific electronic or software technologies, but I can give you an overview. So the first one is the one where the monitoring is mostly concentrated. It look at the diseases and it is able to locate the diseased plants and visualize them. The drones flies by itself in a routing that is established but flexible. So there is less work in terms of piloting if it is possible to fly the drone with the weather conditions. So it is an automated process that monitors diseases. Data is collected, processed, and it creates mosaics images using a series of software, and it calculates a certain set of parameters that are useful to establish the health of the vineyards. So you can see the similarity and why I put one after each other, basically, these two projects, because they are closely linked and they are both contained in the area of monitoring. The second one is the drone spraying, developed in Greece, and is basically a drone that is able to put agrochemicals on different types of crops, mainly vineyards, but they are testing it on different kind of crops. And basically, we try to develop a comparison between standard techniques and this one, with the intent of reducing the costs related to the use of agrochemicals. So it's an exploration on the capabilities of drones to see whether they are more efficient or not, and to promote their development in terms of spraying. If this is successful, it will be possible to convince gradually the European Union to adopt a regulation that allows spraying drones to be used in agriculture. So this is our main goal, because at the moment only experimental fields are the areas where spraying drones can be used. Sorry, there is a link here where we can show the spraying drone in action. We don't need to see the whole thing, but this is an example of the material that you find on the YouTube channel of ICAERUS. Number 3 is the livestock monitoring. You see the cows here, but it works as well. There are sheep here as well. When they do the demonstration is the one that I would like to attend, because it's really nice to see the animals moving and find if they are moving in the right way using a drone. So why this is important? Because we love these animals, but nobody wants to take care anymore of them. So there is a shortage in labor. So it's really important that we preserve the quality of the life of animals and livestock, at the same time using technologies, because nobody wants to take care of them anymore in our developed Europe. Forestry and biodiversity is a very interesting use case, in the sense that it looks at the health of forests in terms of trees, at the risk of fire, especially consider the south of Europe and the regular fires that we see every summer. And then the monitoring of wildlife, so wild boars, bears, etc. So it's basically a drone that is able to detect different kind of situation, and it has also an infrared camera to go beyond the level of the trees and see whether there are elements that resemble the shape of different animals. So it's empowered with an artificial intelligence that compare with the shape of the different animals. So basically they are developing 3 methodologies, one for tree health, one for fire risk, and one for wildlife assessment and monitoring. This will create a map that can be updated more regularly, also to advise people on what they can find on the forest. Why this use case is important? Because not only farmers can benefit from drones, but also foresters, so basically every user of a forest, people who go for hiking in the Alps, or governments, NGOs that manage parks, and they want to monitor the risks connected to several aspects of them. Number 4 is, this is an example of the application at a national, regional and local level. So you see different levels of details in the maps, so they can highlight an area, but they can drill down to a specific parcel. Number 5, and it's the last, the rural logistics. So here you see 3 types of drones. One is the traditional one, the multicopter. Then we have the helicopter, and this one that resembles more an airplane. So basically they provide the delivery in a fleet. So it's a fleet management system that is able to manage different kind of drones and deliver parcels in conditions where the normal delivery is not that easy. So disasters, but also conditions where the normal delivery will take more time because perhaps we need to cross a valley. So in certain cases we can use this kind of technology. Basically it's implemented through a very sophisticated software part, perhaps the most sophisticated of the whole project, because it has different modules, from the authentication of the user, the role-based access control, the profile for the navigation, so the altitude, the weather, everything is considered because it navigates beyond the line of sight. So the drones will not at a certain point be any more visible, which is the critical part of piloting drones. And it is able to optimize the routing through an operational research algorithm. Again, summaries that you have seen at the beginning. I hope it was useful, interesting as a presentation for everyone. If you want to know more, the link of the project is up there, ICAERUS.eu, and from there you can also access the link to the first week of the course, and again by Christmas the full course. My email, if you want to get in touch, I will be pleased to talk to everyone who wants to know more. Questions? Thank you.
Thank you. I open up the room for questions at the moment. I actually have a couple. One is more on the project management side, and the other one is more technical, let's say. The first one is about the open calls. How many projects did you finance with the open calls? I believe we just got the first round, right, of open calls.
No, we closed the open calls.
We closed okay.
All of them.
All of them.
So the last one is under evaluation, so we still do not know how many will pass the review. So if we have still funding available, we reopen another open call, but at the moment is not given.
Okay. So, and the number of projects are under evaluation in this, okay. I missed that information.
Yeah,
sorry.
I need to click.
No worries. I got the answer.
I think 20.
Okay.
20 projects in total will be founded, 12 of one type, so push open call, and 8 pull open call, or the other way around. Basically, one type is developing a technology, the other one is developing a business idea. So the business idea come later, so the last call that closed recently was a business idea. So taking the 5 use case technologies and developing something that is able to reach some business interest.
And the other question is, I saw the use cases are, located in different parts of Europe, along the partner countries, and a few of them are actually really linked together, because in a farm we could have monitoring, spraying, livestock maybe, and logistics as well. Maybe forestry is a little bit out of the range, but actually I see four of them actually useful for farms. Is there any idea to find a connection among these four use cases? For example, how to transfer data in a common way or in a standardized way, so that with a single platform, maybe you can utilize all the four use cases, all of the four applications, let's say.
So I answer in two ways. The first way is the standardization of languages of data. Yes, Word Package 2 worked a lot at the beginning in the first year to develop a common protocol for presenting the software, because otherwise the 5 use cases would have taken 5 different directions. Instead, they standardize the way libraries are presented, and Wageningen University is the one that approves everything in terms of what the final user will see of that Word package. So there is this entity looking at the quality of the software developed. At the same time, a business development. So can a company integrate more? We hope so. Here we do not have, like in all Horizon project, our intent is not to create revenues, but we found companies that can grow. Since the industry is at the very beginning, companies are not very big, so they will integrate services one after each other. And you see the example here of Agrobit that is offering progressive level of services, integrating more and more. We hope that with the ability to give them funding, but also expertise and knowledge and access to different kind of expertise, they will develop even more, not just you, but all our recipients.
Okay, thank you. Any more questions from the audience? It is not the case, so I'd like to thank you.
Thank you
Thank
for
you very
attending.
much for being here and presenting the ICAERUS project. With that, I would thank you everybody, because this is the last event in this EIMA Digital Terrace for this year. I believe that this initiative will be repeated in a couple of years in EIMA 2026. Thank you for being here. Thank you to our speakers, and have a great EIMA.